Welcome, everybody, to your GMAT Prep Hour. My name is Reed Arnold. I am chiming in from New York City, New York. It is February 21st, 2023. If you're looking for other free GMAT prep options, we have a few. First and foremost, you can try any of our GMAT classes live or online free of charge. I was just talking to one of the attendees about this in the chat box before the recording started. Highly recommend that you go to those, even if you have no intention of signing up for a course. We talk about some major stuff in class one, in particular data sufficiency. We talk about some major strategies for that very weird GMAT specific question type. So I always encourage people to take 3 hours and attend 10% of our class for no money, because I do think you will find it very helpful. You can do a similar thing with our interactive course, the video course we have called Interact. You can try a sample of that and our kind of self-paced syllabus if you're more the self-paced kind of studier. And I'm also pleased to announce that we have 2 free Foundations of GMAT math workshops. Previously, this course had been one gargantuan 7-hour day. We have changed it now to 2 4.5-hour days. The order does not matter in which you take these. One of these sessions is on variables, so that's kind of more in the algebra, setting up equations kind of situation. And then the other is on computation. That's in the actually doing the arithmetic, ways to do mental math quickly on account of the GMAT doesn't give us a calculator and we are asked to do such a thing. So if you're interested in these other free options, take a look at this link. There's also recordings like this. We have a whole library of free GMAT prep hours on our website, or I'm sorry, not on our website, on YouTube. I encourage you to seek those out because frankly, there's a whole syllabus there for you. You could be exposed to pretty much everything you would need to get a great score on this test. So today, what we're doing, I thought it might be kind of a handy tool to have out there. I'm just calling it a quant diagnostic. And so if you're new to studying, this is kind of a good, just kind of first step. If you've been studying for a while, I think this is a good check-in to see like, okay, what am I picking up? What am I short on? What am I missing? What do I need to shore up? And the idea tonight is I've picked or created a slew of questions in GMAT Quant that jump around from topic to topic, but in general are meant to touch on some of the big things that the test will test you on. The big strategies, the big habits, the big mechanics, some of the big concepts for sure. This is not going to be a totally exhaustive list, but I think it'll be a pretty good checkup. And I think the thing I would say about this is these questions, you know, if you're going for, let's say, a 670 or above, if you're going for a 670 or above, I think most of these questions are ones you would hope to get right in about 2 minutes, right? These should be sometimes somewhat challenging, but not like gargantuanly challenging. These are not mostly easy questions. Some of them are on the easier side, but none of these are meant to be like true break your brain quant problems. That doesn't mean that they're easy. I know I'm talking on both sides of my mouth now. It doesn't mean that they're easy. It's just meant to be a check-in, I think, you know. It's meant to be a litmus test for you. If you're going for this score, are you where you need to be at? And if not, that's fine. You have plenty of resources to improve. And what I'm going to do, I'm going to list the resources that we offer to improve on the material that question is testing. Okay, so this is just meant to be a place where you can come, try out a problem. If you get it right, and it's pretty easy, and you get it right in 2 minutes, great, you're good to go on that one. That's you know, check that one off. But if you struggle, if you don't get it right, or if you get it right and it's lucky, or if you get it right but it would take you more than the time, I'm going to cut it off at about 2 minutes because again, I want this to be a good diagnostic. So if it would take you longer than the time I give, it's probably worth cracking into the resources I list, revisiting these topics, shoring up these strategies, because I think they indicate that there's probably, if you miss these questions, I think it's a good indication that you have not mastered what is needed for this test to score above a 670 on or the quant equivalent of a 670. Okay, so that's what this is meant to be. The resources I will list for the topics and strategies based on the questions that we do are in these 6 places. One, I'll just point out, for those of you that are taking Manhattan Prep courses or are interested in Manhattan Prep courses, I'm going to tell you which session we will discuss the material or sessions, the material in that question. Similarly, I will tell you which sessions in the Interact syllabus, that is our self-paced video course, I will tell you where to find those. I will tell you which chapters in our Foundations of Math manual, if the question has relevancy with that book. I will tell you which of those free variables or computation Foundations of Math seminar we discuss something related to that question. I'll tell you what chapter in the All the Quant manual you can find material, and I will also tell you which other free GMAT prep hours, that's these here in our YouTube library, you could access to learn what is discussed on that question. Because again, the idea here is that if you miss a question, I know it's harsh to do one and done, but I'm basically saying if you miss this question, it means that you have not mastered the skills enough to break a 670 equivalent quant score. You know, that's what this is again meant to diagnose. There are other resources out there, message boards, blog archives, but these are the 6 I'm going to list tonight. Okay. Before we jump in, a quick just data sufficiency recap or introduction for those of you that have never done this before. Data sufficiency is a very strange GMAT specific question type. It will look like this. You will have a question up top. Uh-oh. Sorry, one second. I have to move this window. Okay, you have a question up top. You will have 2 statements about this question, and then you will have 5 answer choices that tell you, they're always the 5 answer choices, always in this order. And what you're trying to say is where in these 2 statements you have enough information to answer the question that is asked. That is the idea for this. Okay. So if statement 1 gave you enough information to tell you how many employees were senior managers, you would say statement 1 was sufficient to answer that question. Okay. And you would choose an answer choice that said statement 1 is sufficient to answer that question. That would be answer choice A and D. If statement 2 was sufficient, you would choose an answer that said statement 2 was sufficient. That would be choices B or D. Okay. If the statements together are sufficient but not alone, meaning you need both of them, but once you have both of them, you can answer the question, you would choose C. That is the answer to this particular question. We're not really going to do this one, but if you're curious, that will be the answer to this problem here. And if there's no sufficiency, this is frustrating. Sorry, the poll keeps jumping into the screen. I don't know if you all see it, but it's jumping into my way. If the 2 statements together are not sufficient, you will choose answer E, and that means there's just not enough information to answer the problem here. Okay, so it's a very weird GMAT specific question type. If you haven't seen this before, this is one of the first things to master, and we will definitely do a question or 2 that will check in on this specific thing. Have you mastered the data sufficiency, organization, and process? But that's a quick overview of how this works if this is your first time seeing this question type. So without further ado, we're going to jump in. Okay, I'm going to pull up our first question of the night, and I'm going to give you 2 minutes to answer, and I'm going to cut off pretty firmly at 2 minutes. So let's clear the poll. Go ahead and choose an answer when you have it. Ready, set, go. About 30 seconds, 25 or so. All right, that is 2 minutes. I'm going to stop it there. And if you're watching a recording, okay, I'm going to ask you to stop as well. Remember, I'm going to kind of stick to the time today because I really want this to serve as a diagnostic. This is also a question probably on the easier side for GMAT in GMAT terms. So this is probably one where even 2 minutes might be a bit long. If you're going for 670 or above, you probably want to get this a bit quicker than that. But this is really just meant to be a check-in to make sure that you're clear on the data sufficiency format, the high-level game that's being played with questions like this. So this question is asking a pretty straightforward question: what is the value of y? If I studied for the GMAT for a while, I'm going to specify that that is a value question. There are two major kinds of questions for data sufficiency: value and yes, no. This is asking for a value. So I go to statement one, I make my what we call the elimination grid. Organize my answer choices A, D, B, C, E. Statement one tells me y is an odd integer, odd int, between 28 and 34. And I can tell that that's not going to be sufficient because there are several odd integers between that range that works: 29, 31, and 33. I don't, even though that helps me, I narrow down from infinite possibilities to 3 possibilities, it's still not enough to tell me what the value of y is. So I get rid of A and D because statement one on its own is not sufficient. Statement two tells me 31 is less than y is less than 36, and this is also not going to be sufficient because there's 32, 33, 34. There's also non-integer values. I'm not told up front that y is an integer. And so that's not going to be sufficient. I'm going to get rid of answer choice B. And now, only after I work through the two statements together will I bring, when I work through the two statements alone, do I bring the two statements together? Okay. And I know that y, I wrote 36, it should be 34. I know that y is between 31 and 34, and that it's between, oh no, I'm sorry. It was 36. I'm jumping ahead. Okay. Now, when I bring these two together, the 36 and 35 that are possible in statement two are actually cut off at 34. 34 is actually now the high end of y. And now 28, 29, 30, those are all cut out by statement two. 31 is now the low end. So y is between these numbers, and y is an odd integer. That's what statement one tells me. And now there's only one choice. Now there's only 33. 32 doesn't work. 34 is even and also not in the range. And if you're wondering about 31, 31 is not included. Notice that this is a strictly non-inclusive inequality. So I can't choose 31, and I do know that it is an integer from statement one, so I would choose C. Okay. That is the process for this problem here. If you found that you missed it or were struggling on it, here's where you can look to brush up on some data sufficiency skills, because this was just the basic process of working through and making eliminations. Had a light testing cases flavor, but not huge. I would focus first on the big data sufficiency process. So the first session of our course or our interact will go over that. Chapters 2 and 10 of our All the Quant book will lay out data sufficiency. And then there's some free GMAT prep hours on data sufficiency and testing cases that you would find helpful. All right, and with that, quick interlude. Those that are here live tonight are able to enter a raffle. I'm going to put that raffle in the chat. Enter that for a drawing at the end of the month for a chance to win a MacBook Pro or AirPods or a Kaplan in-person course for one of several available test prep courses. Okay, so make sure you click that link and enter what information they ask for. I hope one of you wins. Up next, another question from, by the way, Most of the questions today are from official GMAT prep materials. That means this is an official question from the company that makes the GMAT. Most of them will be today. I've made up a few that are in the GMAT style, but look at the bottom right corner to see if it's an official question. So this is another official question from the prep materials. Take 2 minutes. Poll is up. Choose when you have an answer. All right, that is 2 minutes. And again, I'd stop you there for the purpose of the diagnosis today. For those of you that are trying to break a 670 quant score, that would be the time by now you would hope to have an answer. If you want to pause, if you're at home, you can pause and keep working, but just know that that is the for the purpose of the day, I'm going to call that time. Okay, so this question is dealing with percents. We have a car dealer who sells one car at a profit of 25% and another car at a loss of 20%. And we know both cars actually sold for $20,000. A few ways to handle this question, a few ways to organize. I'll show you a few. One is to kind of use straightforward algebra if you want. So you could say, okay, we sold one car at a 25% loss. I'm sorry, 25% profit. So we had the initial cost plus a 25% profit on that cost. And that is what we got for $20,000. So I end up with 1.25 times the original cost of that car to the dealer. That gives me 20,000. This is the kind of thing I would probably turn into a fraction. And you want to be as fast as you can on these fraction to decimal conversions, or decimal to fraction to percent conversions. The faster you are, the better. So you can say 5/4 x is 20,000 multiplied by 4/5. 20,000 divided by 5 is 4,000 times 4 is 16,000. And so I know this first car that made a 25% profit, it was bought for 16,000, sold for 20. That's a $4,000 profit. Do a similar thing for the loss car. I could say a 20% loss. So if I'm doing kind of straight algebra, straight translations, the original, I'm using a different variable, the original price minus 20% of that original price gets me to the 20,000, which would be 0.8 y equals 20,000. Turn that to a fraction, 4/5 y equals 20,000. Multiply both sides by 5/4. 20,000 divided by 4 is 5,000 times 5 is 25,000. And so this one, if it was bought for 25,000 and sold for 20,000, was a $5,000 loss. And so when I combine these two, I lost $1,000. So the answer to this question will be C. The most likely mistake people would make here, I suspect, is to get to say, okay, a 25% profit, well, 25% of 20K is 5,000. And so you say, okay, well, that car that made a 25% profit had a 5K profit. And 20% loss, okay, well, 20% of 20K is 1/5 of 20K is 4,000. And so that was a $4,000 loss. So here, if I did this math, I got a profit of $1,000 and I choose answer choice A. But the problem here is that you don't want to get a percent of the selling price. The 25% gain was on the original price to the dealer, and the 20% loss was on the original price to the dealer, not on the selling price of the dealer. That's what will typically lead people to choose answer choice A here. Okay, so that might have been what some of you did, because there are some A's in the room. Another way to work through this question that I rather like is to use ratios and to turn this quickly to a ratio. So for the car that made a profit, I know that it was a 25% profit. So I know that that's a 4-to-5 ratio. If I've practiced this, I know that this is a 4-to-5 ratio, purchase price to selling price. And I know that the actual selling price was 20,000. So I can use my unknown multiplier of 4,000. By the way, if this looks like nothing you've seen before, it very well might. I'm going to point you to some resources that teach you this method. But I think this is a method you definitely want if you're going for that high quant score. So I know that this original purchase price is 16,000. That's for the car that made a profit. So that's a profit of 4,000. Again, we know the answer already, but I know that's a profit of 4,000. For the lost car, that was a 20% loss. So I know that ratio of purchase to selling was 5-to-4. And again, I know the actual selling price was 20,000. So that's a multiplier of 5,000, which means the original purchase was 25,000. And again, that is a 5,000 loss. Okay. I'm very much like turning percents to ratios. I find it sometimes a little bit easier than trying to build equations and solve equations. If you found yourself struggling on this, if this method seems weird to you, if you felt like it was just a little slow, here are some resources that are available to you to practice everything that you need to get this kind of question right quickly. 2 and 4 of our course. We do this kind of stuff in our computation lesson in the Foundations of Math. The Foundations of Math chapters on 4 and 5 are on fractions, decimals, percents, and ratios. You should definitely consult those if this question gave you some trouble. All the quant chapters 3 and 5 are on fractions, decimals, percents, and ratios. You should consult those. And we have an army of free GMAT prep hours on this stuff. Okay. For both the percent setup and the ratio setup and all this other stuff in between. Obviously, I should also be clear. Obviously, in these resources, you're going to get all sorts of other things as well. These resources don't deal with just the material on this question. But if you're struggling with these questions, the things you need are in these places. Okay. And percents are just a GMAT staple. You know, they're guaranteed to show up on a test, it seems. So you want to be really good at percents, fractions, ratios. You want to know how to set up and solve these quickly. All right. Next question, again from the official GMAT prep materials. Take 2 minutes. Thank you. Rich, poll is up. I can answer when you have it. We'll let this one go a little bit longer than 2 minutes. Okay, that's about 220. And I think if you're going to score above a 670 equivalent quant score, that by now you'd want to get this question right. Now, I like this question because it looks awful. And it's not easy. And it's really not easy if you're trying to do kind of pure math stuff. But it's, according to the data anyway, a medium difficulty question, at the high end of medium, I'm sure. But that's because people who have studied the GMAT have figured out how to do a question like this quickly in a very GMAT way. And if you've seen any of my videos or seen any of our videos, you'll often hear us talk about, GMAT methods and not sticking to classroom math quite so much, because that's something the test ultimately will reward, is actually being a little bit scrappier and not quite as regimented as our classroom math taught us to be. And what a good GMAT studier, an experienced GMAT studier recognizes is first off that, okay, there are variables in the answer choices. Variables in the answer choices is a pretty clear sign to think about picking your own numbers. It's a pretty clear sign that that's a good idea. And that is going to end up being a very key thing here. Now, in order to do this, you do need to have a good understanding of how functions work. And again, I'll if that is what stuck with you on this question, if you figured I can pick my own numbers, but really didn't know how to deal with the function aspect of this, again, I'm going to list the resources to go to shortly. But what we're basically saying is, hey, for which of these answers, if I plug in a number X, do I get the same result as if I plugged in 1 minus that number X? And so what I would do is I would just pick a nice easy number X here, like 3. And I would just think about what f of X would be. So that's what f of 3 would be, and what f of 1 minus 3 would be. So that'd be 1 minus 3 is minus 2. And I'm now just going through my answers and saying, okay, well, if this is f of X, what is 1 minus 3? Minus 2. What is 1 minus minus 2? 3. We're looking for equality here. This is not equal, so A is out. This needs to be true for all X. If even one X makes this not true, it's not the answer. So A is out. Answer choice B. If I plug in 3 into this function, I get 1 minus 3 squared, 1 minus 9. That's minus 8. If I plug in minus 2 into this function, I get 1 minus 4. That's minus 3. Well, that's not the same, so that's out. If I plug 3 into this function here, I get 9 minus, and I'm going to keep track here because I don't do this in my head, 9 minus 1 minus 3. 1 minus 3 is minus 2. Minus 2 squared is 4. So 9 minus 4, which is 5. And if I plug in minus 2, I get 4 minus 1 minus minus 2 is 3 squared. 4 minus 9. Is 9 minus 4 4 minus 9? No, those are different. So the answer is not C. See the pattern? I'm just plugging and chugging. Plug in 3 here. 9 times 1 minus 3 squared, so 9 times 4. Plug in minus 2, I get 4 minus 2 squared times 1 minus 2 is 3. 1 plus 2 is 3. 4 times 9. And for the first time, I actually have an answer that's equal. 9 times 4 is the same thing as 4 times 9. And so I'm going to leave it. I might not choose yet because I might maybe have chosen numbers that get the same answer for E as well, or the same number for E, and then I'd have to choose a different set. I don't think I did, though. Let's find out. 3 over minus 2, 1 minus 3. Does that equal minus 2 over 3? No, it does not. So the answer is not E. And so I know the answer is D. just by testing X or just by testing 3 and 1 minus 3, which is minus 2, and seeing which answer got me the same number twice. And someone who's done some GMAT practice and is pretty proficient at knowing when to pick numbers and has a good enough understanding of functions to know to just plug and chug stuff. That's often what function questions end up being. Okay, this question is gettable in 2 minutes. If you found yourself struggling with this, either the strategy or the function aspect of it, we go over functions in session 5 of the Manhattan Prep course or the Interact if you're doing the self-study. Okay. All the Quant in that book, chapters 4, 13, and 15, will go over the strategies and subject matter here. Consult that. If you struggle on this one, and it seems like this room probably did a little bit, that's fine. That's what this diagnostic is for, is to identify sore spots. We do a little bit of talk on smart numbers like this, picking your own numbers for variables in the Variables Foundations of Math seminar. So if you want to attend the next one of those, it will be in March. And we have free GMAT prep hours on this topic and the strategy, getting familiar with functions, picking numbers and problem solving, and the problem solving toolkit, which goes over all sorts of strategies that you will use for GMAT problem solving. Okay. So if this question gave you some grief, there you go. Reach out to those resources, shore up these skills and this concept. Onward and upward, a word problem here. This one I made up, so this is not an official question, but it's close enough to one, and it tests the skills that one would. So take 2 minutes. Let's see where we fall. That is 2 minutes. Again, for the sake of today, I'm going to shut it off there. If you want to pause and keep working, you can, but for diagnostic purposes, okay, here's your diagnosis. This is testing, setting up and solving equations in a word problem. Okay, very common GMAT thing to have to do. There are a few different approaches to this. I'll show you both. I think the first and the one that might jump out to you most is to use translations in algebra. Okay, now in order to do that, we need to translate carefully. We need to make sure we don't mix up the equation here. There are 30 more cow feeders than horse feeders. So that means I need to add 30 to the number of horse feeders to get the number of cow feeders. Okay. So cow is age plus 30. It's very easy to mix that up and say, oh, 30 more cow feeders, 30 plus the cow feeders is the horse feeders. Nope, that would be a mixed up. That would lead to a wrong answer. careful about that translation. One thing we advocate in our Foundations of Math class is to actually draw just a little visual representation of this. If there are 30 more cow feeders than horse feeders, I know that there are more cow feeders. Cows needs to be bigger. So cow, horse, and then, okay, that's a 30. Because it's a 30 more difference. Okay, cool. So H plus 30 is C. That representation will assure that you translate the first equation right. And then each year we add a new feeder for each type of animal. Okay. In 14 years, there will be twice. Okay, so now we're saying in 14 years. So we added 14 feeders on top of this. There will be twice as many cow feeders as horse feeders. And here's the thing to be careful of. It's easy to say, oh, well, in 14 years, there's C plus 14, and that's twice the number of horse feeders. So C plus 14 equals 2H. But again, that would be a mistake. One thing I've started to do, and I know my colleague Whit does because she taught this to me, before we even build equations, before we even build this one, you can kind of lay out your unknowns. And by unknowns, I don't just mean C and H. That's the current number of feeders. So C is the current number of cow feeders, and H is the current number of horse feeders. And before I try to build any equations, I think about, okay, what other unknowns are there, right? What other values do I need to know? Well, you know how many cow feeders there are in 14 years. And so that's going to be C plus 14. That's the number of cow feeders in 14 years. And I also know there's going to be H plus 14 horse feeders in 14 years. And then what am I asked? I'm asked for how many horse feeders will there be in 3 years. Notice I'm not asked for H. I'm asked for H plus 3. And so I'm going to put that up top and actually circle it. Here's the question. Not H, H plus 3. And I suspect some of you have perhaps realized a trap. This is just attention to detail. Good habits to lay out what is given and what is asked early first, before you do any work. Make sure you set that up right. And it's from these unknowns that I set up the correct equation for that second one, because what number is twice what number? Well, the number of cows is twice the number of horses, and that's cow feeders and horse feeders. And this is how many horse feeders there are. And now I can do some substitution. I can say, okay, well, H plus 30 is the number of cow feeders. So I plug that in for C equals 2H plus 28. And now I'm off to the races. That's 44 equals H plus 28. So 16 equals H. Now, of course, 16 is an answer here. It's very tempting to choose it, but we're not choosing 16. We're not solving for H. We're solving for H plus 3 in 3 years. So that'll be 16 plus 3, 19. Okay, so the answer here is B. And algebra definitely works. And, you know, substituting and solving equations, definitely something you want to be able to do, definitely something that you'll need on the test. But it is worth noting that there is another approach here, and one you also want to be good at, and that is working backwards. In many word problems, you can use the answer choices to your advantage. Specify what those answers are, right? These are the horse feeders in 3 years. And it's going to be either 16, 19, 30, 46, or 60. Well, if those are the number of horse feeders in 3 years, and I know they're adding one a year, I can figure out how many horse feeders there are now by subtracting 3. 13, 16, 27, 43, 57. From that, I can figure out how many cow feeders there are now. Because there's 30 more cow feeders. So 43, 46, 57, 73, 87. Notice I'm just vomiting out piece by piece not even really thinking. I kind of just go into computer mode. Just, okay, I know this value, this would be the other value, this would be the next value. You can go one at a time, but I kind of find it helpful to just go into autopilot to some degree. Now I have to think about, okay, what happens in 14 years? So in 14, I'm just going to put this underneath. So that's going to be 27, 30, 40, 41, 57, 71. That's just adding 14 to the horse feeders. And then I add 14 to the cow feeders. 57, 60. And I'm actually already done. So I'm just wondering, hey, when do I have twice as much? And the answer is in number 2. 30 times 2 is 60. Okay. And back solving is a totally good way to solve this question. Hayden, do you have to infer linear scaling of feeders? I think it's in the sentence here. A new feeder is added for each type of animal each year. A new type of, a new feeder. So one new feeder. So maybe I should have specified one, but I feel like that's unambiguous enough that the GMAT would allow it. Okay. And so this kind of, the math isn't too rough here. I'm subtracting 3, I'm adding 30, and I'm adding 14. It's totally doable here. And you want to be able to back solve. I promise you there's going to be a question or two on your test where back solving is easier than algebra. Even if you're looking at this algebra and you're like, that's easier on this one, I'd rather do that. Okay, sure. But I promise you there will be a question where it's not, where back solving will be the easier approach. You want to have it in your pocket. Again, here are your resources for translating and solving linear equations like this. Session 3 of our course in Interact, chapter 6 and 9 of the Foundations of Math, 4, 9, and 17, and all the quant. That will cover translating. That will also cover substituting and substituting in combination. That will cover working backwards. We do this kind of work in the variables Foundations of Math seminar, and we have free prep hours galore, translating English to math. And just that's the purpose there, is to work, as you kind of saw me do, carefully, step by step, one piece at a time. You don't just try to vomit out an equation. It's too easy to make a mistake. You translate one thing, and then you build the whole model. Linear equations, working backwards, and then the problem solving toolkit. Okay. All right, onward and upward. Another data sufficiency question. Okay, take 2 minutes. Let's see where we That is 2 minutes. The clock there. We here in the live session are split on this one perfectly 50-50 between A and B. All right, so if I was working on this one, first up, specify what's given and what's asked. Nothing is given, but we're asked, is P an integer? I would note that unlike the last data sufficiency question we saw, that was asking for a value, this is a yes/no question. Not much else to do with this one. I'd move to the statements, A, D, B, C, E. Statement 1 tells me that 3P is an integer. And at this point, I would launch into testing cases. This is a straightforward testing cases data sufficiency question. Pretty common question type. Testing cases is one of the biggest strategies you'll need for this test. You want this to be absolutely locked down. What would I do? Well, I usually like to set up 3 columns where I have my case that I'm going to test, the rule that must be followed, and then the question that I'm trying to answer, is P an integer? For now, there are kind of 2 options for this one. For now, I'm going to do the more standard maybe testing cases, which is to pick a P first. And you want to pick a nice, easy, just pick any case that's going to easily follow the rules here. 1. Okay, is 3 times 1 an integer? Yes, it is. Is P an integer? Yes. And my goal now, and you want to have testing cases down that this is just completely automatic. I want to think about a case where P is not an integer, but the rule is still followed. Can I make P not an integer, but 3P an integer? And once I think about it, yeah, I can. 1/3. 3 times 1/3 is an integer. That equals 1, right? So, okay, yeah, rule is followed. Is P an integer? No. And this, if you've tested cases a lot, you know this is what proves insufficiency. Statement 1 is not sufficient. Because P could be an integer or it could not be an integer within the confines of this rule. 3P is an integer. When people mix up testing cases, it's almost always somewhere getting crossed up on the question and the rule. People start treating the rule like a question. And it's not, it just must be true. The other way you can go about this, by the way, is to follow the rule first. To just say, okay, 3P is an integer. Well, what could 3P be? That's an integer. 1, 2, 3, 4, 5. Here are integers for 3P to be. Well, if 3P is 1, P is 1/3. If 3P is 2, P is 2/3. If 3P is 3, P is 1. And we have our is P an integer? No, no, yes. There we go. 2 different answers, no and yes, in cases that I just know follow the rule because I started by following the rule. This method is going to be even more useful for the second statement that tells me P/3 is an integer. Because if I follow that rule first, if I just think about, okay, well, what number is an integer that P/3 could be? Well, let's say P/3 is 1, then P would be 3. Is P an integer? Yes. Great. Okay. What if P/3 is 2, then P is 6? Well, that's an integer again. What if P/3 is 3, then P is 9? Well, that's an integer again. And I'm starting to see a pattern. What if that's 4? That's 12. Okay, I'm done. It's an integer. P is a multiple of 3. I'm good. I know that this is going to give me a yes answer every time, and the answer to this question is B. If you went with a case first approach, you can say, okay, P is 3. That follows the rule because 3/3 is an integer and P is an integer. Now the question is, can I get a no? And that means I want to test a non-integer. So let's try 1/3. Well, 1/3 over 3 is 1/9. It's my fraction rules, dividing a fraction by 3. It's like multiplying by 1/3. And 1/9 is not an integer. And so what this means is that I throw this case out. It doesn't tell me anything about sufficient or insufficient. It just means P is not 1/3. So it's like, well, okay, what about 3/4? What's 3/4 divided by 3? It is 3/4 divided by 3 is 1/4. And that's also not an integer. So I throw that out. And I'm done. I don't want to keep testing. I think this is not going to work. The only cases that are going to work will be integers. Statement 2 is sufficient. So this is a pure intermediate testing cases question. It's one that if you're going for a 670 or above, you want to be totally automatic on in time. If you want practice on this, again, our first sessions in the course or Interact go over data sufficiency and testing cases pretty thoroughly. Chapters 2, 10, and 13 of all the quant. I should also include here maybe some fraction, the fraction chapters that were mentioned before. Where were those? Some of these chapters here, 3 and 5 in the foundations, 4 and 5 in the foundations, 3 and 5 in all the quant. There might have been some fraction stuff that threw you off here. But all this data sufficiency and testing cases stuff are here, and we have free GMAT prep hours on it, data sufficiency mastered, rephrasing and testing cases and quant. All of these will dig into the topics of testing cases. You want it to be automatic. All right, onward and upward. I'm gonna go a little bit long today because I do have a few. I just want to make sure I get through these because again, the purpose today is to get a wide diagnosis. Take 2 minutes here. That is 2 minutes for the sake of today. Call it there. So this is to check in on your exponent mechanics, making sure that you are shored up there for the high 600 scores. First thing I do when I see an equation with a bunch of numbers and exponents is to turn numbers into the common bases to kind of pare them down as much as I can. So 4 is 2 squared. So instead of writing 4 to the 11th, I'm going to write 2 squared to the 11th. And instead of writing 10 to the n, I'm going to write 5 times 2 to the n. So I have 2 times 5 times 2 to the n. And now I'm just using my exponent rule. So 5 to the 21, 2 squared to the 11th is 2 to the 22, equals 2 times, and I know that this is 5 to the n, times 2 to the n. And now I can use my exponent rules here on the right. 2 times 2 to the n is 2 to the n plus 1 times 5 to the n. And so I look at this and I look at this because these are equal numbers. And I think, okay, well, 5 to the 21 and 2 to the 21 plus 1. Looks to me like n is going to be 21, and sure enough, that is what it is. So this is just, again, standard intermediate exponent mechanics. If you need to brush up on this, we got you covered. Session 3 of our course covers this. Chapter 3 of our Foundations of Math manual, chapter 11 of all the Quant, the Computation Foundations of Math seminar, and we have 2 free GMAT prep hours, exponent workout and exponents revisited. That will brush you up on all your exponent rules and mechanics. If this one gummed you up and you're going for that score, dig into these. Shore up your exponent work. I'm just going to keep flying through. Take 2 minutes here. Thank you, Rich. Poll is up. That is 2 minutes. Let's call it there for today. Back to data efficiency. Okay, and back to testing cases with a little bit of a twist this time. We're in a yes/no question. Is X greater than 10? Okay, it's a yes/no. Not a lot else to do here. A, D, B, C, E. Statement 1 tells me X squared plus X is greater than 110. If you're in math class and you're trying to do algebra here, that's going to be a bummer. It's much better to just kind of, again, test cases. Well, okay, what if X is a billion? Huge. What if X is just really big? It's going to follow the rule and X is going to be greater than 10, right? You can test cases without actually testing a case. You can just test like the idea of a case. If X is really big, then of course this rule is going to be followed, and X is of course going to be bigger than 10. Going to extremes is a helpful testing cases strategy. Well, now we have to think about, could X be less than 10? 1 isn't going to work because it doesn't follow the rule, but like negative 100, negative huge, is going to follow the rule because negative 100 squared, that even power eats up the negative. It's going to follow the rule and X is going to be less than 10. So statement 1 is not sufficient. Statement 2 tells me X is greater than negative 12. And that's, again, if you're well practiced in this, you're going to realize this is not sufficient almost immediately, because you can just think, well, it could be 1 or 11. Those are both bigger than negative 12. So that's out. Now we bring the two together, and here's where the real trap in this question lies. Okay. Again, X is huge is going to work. I know that's going to give me an answer. It follows the rules because it's going to follow this rule. It definitely follows this rule, and it's going to be bigger than 10. The question is, can I get a number less than 10 that follows all the rules? And okay, if X is greater than negative 12, but it needs to follow this first rule, you might have a kind of a gut impulse here, like minus 11 is probably worth testing. But minus 11 squared plus minus 11 is 110. And so that doesn't follow statement one's rule, so I throw it out. And if I try minus 10, that's not going to follow the rule either. That's too small as well. And so it starts to kind of feel like, well, if x is greater than minus 12, and this first rule must be followed, then the answer is C. But as I suspect some people in the room figured out, because we have some right answers here, we're not told that x is an integer. And again, someone who's practiced the GMAT notices no integer constraints here. A good GMAT test taker notices when there are integer constraints and when there's not. And so we actually, minus 11 is maybe not the finish line, not the extreme we should go to. What if we test something like 11 minus 11.999999999? It's so close to minus 12 that let's basically call it minus 12. Minus 12 squared is 144 plus minus 12. This would be about 132, and that's plenty bigger than 110 to work. And it's bigger than minus 12, barely, but it is bigger than minus 12. And here x is less than 10. And so it turns out that this is insufficient. The answer is E. I can't answer this question. X is either bigger than 10 or it's really close to minus 12. But I don't know which. So I would choose E. Okay. If you're looking to shore this up, again, check out our first sessions. Chapters 2, 10, 13, and 16 of all the quant. Some of those chapters I've said before. But obviously these are big ones. This is a big strategy. That aspect of considering extremes and remembering non-integers. You want to think about those special cases. Some of that writing can be found in these chapters as well. All right. Onward and upward. Continuing the diagnostic. 2 minutes here. All right, that is 2 minutes. So we'll call it there. This is definitely on the harder side of today's questions, but again, if you're gunning for that score, this is one you want to be able to turn into basically automatic. Few things that experienced GMAT studier might notice. First off, there are no actual values in this problem. everything in the problem is a fraction or a ratio. And that is, again, a clear sign. Every value is fraction or ratio or percent. This poll keeps jumping over. It's very strange. Every value is a fraction, a ratio, a percent, a portion. That's going to ring bells for choose your own numbers again, a smart number situation. An experienced test taker might also notice, like, okay, brand A or chain B has fewer locations, and each location sold fewer croissants. And so if chain B has fewer locations and fewer croissants, it had to have sold less than half. And so chain A had to have sold more than half. That alone gets you to a 50-50. That is some good GMAT estimating, which, by the way, I should have put on this previous question because of that last step where it was like, oh, estimate with 11.9999. I think I should put here, easing your way with estimation, another free GMAT prep hour that is worth your time. Because that's a good mindset, right? I didn't actually do minus 11.999 squared. I just thought to estimate as if it were minus 12. Okay, here I can estimate just like, oh, well, it's got to be more than half. And a good GMAT test taker knows, like, it doesn't matter what numbers I pick here. Number of stores and croissants sold. I just have to fit the ratio. And so I'm literally going to say, okay, chain B has 3/5 as many stores. It's 3 and 5. Each location of B sold 5/6 as many croissants, 5 and 6. And then it's, okay, how many were sold? Well, 3 times 5 is 15. 5 times 6 is 30. Here's the total croissant sold by each chain. Now, I have to be careful, and it's good that I've already eliminated 1/2 because 15 over 30 is a trap answer here. I want to know what fraction of all croissants were sold by A. Well, 30 out of 45, which is 2/3, which is here. Okay, so choosing your own numbers, make them really simple. You don't have to get fancy with this. And use your values to get the total number of croissants sold at each place. Okay, if you're struggling on this one, session 2 of our course in our Interact covers this strategy for smart numbers. 3, 4, 7, and all the Quant will cover this material. The computation seminar talks about smart numbers like this. Free GMAT prep hours, picking numbers, FDPRs. Okay, the problem solving toolkit talks about this. Easing your way with estimation. Again, there's some estimating here to narrow down answers. I'm also going to put the GMAT's favorite equation is a good prep hour to watch here. That's that game of turning the number of chains times croissants sold at each store equals total number of croissants. That's a version of what I call the GMAT's favorite equation. It's in play in this question. It shows up a lot. So if this question gave you some grief, here you go. Dive in, get to work. Plenty to improve on. I know we're going long. Rich, again, if you got to go, I totally get it. I'm going to stick through here just because I want the nice full diagnosis available to students. Take a look back at this data sufficiency question. 2 minutes. See how you do. All right, that is 2 minutes. For the sake of time, I'm going to call it here. And this is the first time tonight in our data efficiency question that another very common, very important strategy comes into play. I'm giving some information about Mary's, Jim's, and Kate's salaries here. I'm told that the difference between Mary and Jim's is twice the difference between Mary's and Kate's. And then I'm asked something about the average. I want the average of Mary, Jim, and Kate. That's the question. It's a value question. And yeah, I can do like Mary minus J. I'm also told Mary's is highest, right? Mary's number 1. And Mary minus J is twice Mary minus K. And if I'm doing kind of some straightforward math, some classroom math, I don't know. I'll be honest. When I was making these slides, I actually didn't even think about doing this. It did not cross my mind when I was looking at questions and I found this question. And I didn't think about the fact that it didn't cross my mind until just this moment. But like this screams to me, and as someone who's studied the GMAT way too much, this screams to me, not algebra. This screams to me set building. Build a set of numbers. I'm asked about the average. And I'm given that the difference, I know I have Mary here, and I know that I have Kate in the middle and James here. And I'm just thinking about the fact that the difference, Kate's basically in the middle. Right? The difference between Jim and Mary is twice Jim and Kate, or Mary and Kate. And so that puts Kate squarely in the middle of this set. And if Kate's in the middle of this set and we want the average, what we really want is Kate. And this kind of upfront work here is what we call rephrasing. It's a very important data efficiency strategy to have in your pocket. You want to look to be able to do it. Sometimes they give you all this information it looks really complicated, but if you untangle it a little bit, you'll realize they're asking actually a very straightforward question. If I have 3 evenly spaced numbers, the middle, the median, is the average. And so I want to know what is Kate's salary. And statement 1 tells me Jim's. Well, that's not sufficient. And statement 2 tells me Kate's, and that's sufficient. I don't have to do any work. Statement 2 is sufficient. The answer is B. If you do upfront work, a lot of times the statement work is like that. Now notice also, with statement 2, I don't know Jim's and I don't know Mary's. I don't know everybody's, but they didn't ask me everybody's. They asked me for the average, which was asking me for Kate's. Okay. Once I know it's 40, I know the average is 40. Jim could be 30, Mary could be 50, Jim could be 20, Mary could be 60. I don't care. The average is 40. This is also a good example of a C-trap. It seems really tempting that, oh, once I know 2 of them, I can plug in and solve for the 3rd, and then I'll know everything. True, but they didn't ask you for everything. They asked you for the average. So if this one tripped you up, 1 in 7 of our course or our interact, chapters 2, 10, 21, and 22 of all the quant. And then free GMAT prep hours, we have several. The value of pre-thinking, that's this kind of upfront work, untangling stuff before you go to the statements. Rephrasing and testing cases, one that Witt taught. Then we have 2 on the material here, statistics and uniformly spaced sets, about just like sets of numbers. So check those out if this question gave you grief. Again, this is one you want to be able to get right pretty quickly if you're going for that high 600 or better score. Okay. Just a few more, gang. Take this one here, 2 minutes. Okay, that's 2 minutes. So I like this question. This is from the official source materials. It's kind of in the world of statistics and sets of numbers again. Okay, it's about, a set of consecutive integers starting at -4. But it's also just a good GMAT example of like, look, this test is often more than anything about being careful not to step into traps. And I don't know if that, we don't have one video about that. That kind of just lurks throughout all sorts of things. But we do talk about drawing pictures and kind of working carefully through some information here and making sure you're not jumping too fast to a conclusion. If I have 12 consecutive integers and I start at -4, it's very tempting to say, okay, well, 12 consecutive integers, 12 plus -4 is 8. But that would actually be too many integers. I don't want to add 12 to -4. 8 to -4 is actually 13 numbers. And there is a formula for this. The last minus the first plus 1 will tell you how many consecutive integers you have. But just think about 1, 2, 3, right? I have 3 consecutive integers, but I only add 2. Here I have 4 consecutive integers, but I only add 3. So I should always add 1 less. So I should actually not add 12. I should add 11. And that's going to be the last number on this list. Now, one other trap here, we don't want the range of all the numbers, we want the range of the positive integers. And again, make sure you have a habit range of positives. Write down the question every time. Because again, you want to not miss any of these. This diagnostic today is, if you're going for this score, you want to go to a place where pretty much all of these is fair game for you. One silly mistake is okay, but eventually, if you're going for that high score, all this stuff, you want to be automatic. That requires care, automatic but careful, right? And so the range of the positives will be 1 to 7. That's a range of 6. Not 7, not 12, not 11. 1 to 7 is a range of 6. Okay. So here for the material of, again, statistics and sets, that's session 7 of our course in Interact. Chapters 18 and 21 of all the quant will not just go over the statistics stuff here, the set of number thing, but also the logicking out of a problem. Just step-by-step logic, careful reasoning, and setting up a problem with an image of some kind, a picture of some kind. That's also in the problem-solving toolkit. Okay. I could probably put uniformly spaced sets on this one as well, actually. A good addition here. All right. Just 1 or 2 more, gang, I promise, and we're done. Try this in here, back to data efficiency. And that is time, 2 minutes. So this will be the last one, I think. The other question or two I had were a little bit too nichey for this more high level game. So we're back to data efficiency. We want to know, is M plus Z positive? Not really a lot of rephrasing to do there. You could say, is M greater than minus Z, but not much to do. That's a yes, no question. A, D, B, C, E. Okay, I go to statement 1. I would add 3Z to both sides. So M is greater than 3Z. You could test cases here. Okay. But I'm kind of just thinking like, well, if M is greater than 3Z, they could both be positive. Or Z could be really negative and M could be positive. And so I guess I am testing cases. Now that I think about it, I am testing cases. I'm just not actually laying out the numbers. I also might think about the fact that on a number line, what this means is that M is to the right of 3Z. M is greater than 3Z, but I don't know if Z is positive, Z is here and 3Z is here, or is Z here? Is Z negative? Is M positive? Is M negative? There's just so much unknown here that this just is not going to be enough to know if the sum is positive. Similar with statement 2, it tells me 4Z is greater than M. Okay, are they both negative or are they both positive? Both of these could be true, and I'd get different answers here. Then when I bring these two together, what jumps out to me most here is kind of a fairly standard GMAT inequality trick, that if an inequality is pointing the same way and you add, you're allowed to combine inequalities, not subtract, but add. So I know that M plus 4Z is greater than 3Z plus M. And then if I combine my like terms by subtracting 3Z and subtracting M, I just get straight up that Z is positive. Now it's easy to then say, well, Z is positive, but what about M? Well, M is bigger than 3Z. And if Z is positive, then M is bigger than a positive number. And so M is also positive. And so if I have two positives, I know the answer is C. Knowing both of these is sufficient. If I continue with the number line game, when I bring these two together, I know that I have 3Z is less than M. M is bigger than 3Z, but it's less than 4Z. And the only way this relationship can happen is if Z is positive. Here's 0. And so they're both positive, so M plus Z will be positive. Either way, the answer is C. But this kind of inequality adding shows up a lot. It's a pretty standard game with inequalities and data efficiency. Be on the lookout for it. We talk about that in session 5 of the MPrep course in our Interact. It's in chapter 8 in the Foundations of Math, chapter 16 in all the Quant. We also talk about this in the variables in our Foundations of Math seminar. And then there's free GMAT prep hours on inequalities and on visualizing relationships on the number line like I did there. And if you wanted here, you could test cases. All the testing cases stuff from before also applies here. If this one gave you grief, if you throw some cases down, you will get the right answer if you're proficient at testing cases and you want to be. So, all right, gang. That's the kind of diagnosis, if you only missed one today and it was kind of a silly mistake, great. You're cooking with gas. You're, cruising into that high, probably ready to aim for those high 600 level quant scores or above. But if several of these, or if all of them gave you grief, again, that's fine. There's nothing wrong with this. Nothing wrong with having some improvement ahead of you. That's totally fine. But there are your resources for it. I'd hope you got a sense of like what strategies or concepts were sticking for you, the things that are sub 600, those things that you need to work on. We have the resources for you in our course, in our books, in our free GMAT prep hours, in our Foundations of Math. Seek it out and keep improving. Don't be afraid of the diagnosis tonight. You need a diagnosis to know what to do. That's why I thought this would be useful. So I will stick around for the live attendees to answer any questions. Otherwise, best of luck in your studies, and I will see you next time.